Today we are going to deal with the
Hofmann
Hofmann
Rearrangement.
This Hofmann Rearrangement. The starting compound it is amide. On this amide, reaction of Br2 will give and finally it will end up with
Like a ketene. Yeah, ketene will form.
so this is a, you can assume this is the intermediate, so this is the final product for the Hofmann rearrangement. Now we have to think step by step how this reaction will occur. Let's see, suppose you have alkyl amide. So this is a C double bond O NH2, it is a amide group. Now you have to add it here
NaOH Br.
Br2. What is the role of Br2? What is the role of NaOH? This NaOH
Bromoxide of
it will give NaOBr plus NaBr. So yes, Br. So here the main base it is NaOBr. Here Na positive and OBr negative. So this is a strong base. Why strong base it is required? As the nitrogen contains a lone pair of electron and it is in, though it is in conjugation, still this nitrogen carrying hydrogen, it is required very strong base to abstract a proton from NH2. It required very strong base. So this is your strong base, sodium hypobromide.
sodium hypoiodide.
Keep in mind, so this is the intermediate base which is formed through this reaction. Now, what will happen? There are the
H.
2H is there. So 1H it was taken by the OBr. So it becomes H.
Then 2 lone pair.
What will be the charge?
Negative.
Simultaneously, very good. Simultaneously, here it is a Br2 present. Here it is a
Br2 present.
So this minus charge, where it will attack on the So you will end up with NBr.
H.
Yes. So another proton. Now this is the electronegative. This is also electronegative. This is now acidic proton. This is now acidic proton. It was taken by the
OBr.
beer OH. It was taken by the
OH.
OH. So it become now R C double bond O N
H.
Br minus. Simultaneously, this Br, it is eliminated, it was removed from the substrate. Br minus. So this Na plus and this Br minus, it become NaBr. Is it clear? So now this plus and minus, it become, we can write it R C double bond O N, a pair of electron, and this is, instead of writing plus minus, what we will write it there? 2 dot means a pair of the electrons. So I can write it like this. Now, writing such kind of the nitrogen where a 2 pair of the electron is present. This is a 1, this is a second. This substrate is called as the yesterday we had seen the carbene.
Carbene.
Today what we have seen?
Nitrate.
Nitrate. Now, so this is a N bromo, N bromo, N
Alkyl bromo.
we should not write NO. Okay. So N bromo, acetate.
Ketone.
This is the acyl group. Acetamide, amide. N bro, acetamide. But did you got this one? This is the nomenclature part of
Yes,
that.
sir.
No need to write bromo. If you simple write N bro, that also enough. That also enough. Or you may write N bromo also. There will be no problem. Okay. Here, the same thing we written it here. Anion. Just put the another word N bromo acetamide anion. Okay. So there was the one things we are studying, catianotropic and anisotropic. Catianotropic already we studied. So this is a anisotropic. It does not mean only carbon containing positive or negative charge. Any atom which contain positive or negative charge. One catianotropic rearrangement we see pinacolar rearrangement. Today we are looking anisotropic rearrangement, the species which carries the negative charge. So that is the anisotropic rearrangement. Now, so this one it is called as the nitrate. Yes, yesterday the carbon containing we call it as a carbene. Same way, these two lone pair of electron and it will get migrated. So you will end up with C triple bond N. What we have to call?
Cyanide.
C triple bond N, cyanide. N triple bond C.
Isocyanate.
This is east side kariye. Okay. So such kind of things will happen in the video. No problem. So now this is the side. This is the isocyanate. So isocyanate. Isocyanate. Did you got it? Isocyanate. This group. Okay. Though it is a double bond, but we can nomenclature it as a isocyanate. Now, what was the ketene? Ketene.
Os
Carbon double bond,
carbon double bond,
oxygen. But here it is not like that because of the nitrogen. Now simply add it here. Water will attack on carbonyl carbon. So it becomes here. Is it clear?
Yes, sir.
Then your final product is
It is not a final product.
now this part is amide and this part is
Acid.
carbamic acid. So this part is carbamic acid.
Acid will remove it.
Now here what will get?
Acid carboxylic acid.
CO2 plus R.
NH2.
Now what is wrong here? This part is wrong here. See, this is the good thing of any mechanism. You can end up with your actual product RNH2 plus
CO2.
plus
CO.
correct? Did you got this one?
Yes, sir.
Na and plus Br minus Na Br. So this is your Hofmann rearrangement. This Hofmann rearrangement also called as the Hofmann bromide rearrangement. Hofmann bromide rearrangement. So either this rearrangement is called as Hofmann rearrangement or this rearrangement is called as the Hofmann bromide
Rearrangement.
See what is happening in this rearrangement. In the first case, the amide which is reacted with the base, that is the sodium hypobromide or sodium oxybromide. So here Na positive, OBr minus. So OBr is a very strong base. So it will attract a proton from the NH. So that NH become a nucleophilic. This nucleophilic NH will attack on the Br2. So it become a N-bromo amide. So again, now here electron withdrawing group, here also electron withdrawing group. If two electron withdrawing group is there, that central atom, it is a contain acidic proton. Yesterday also we had seen, if two electron withdrawing groups are there, so this proton become acidic, that active killing group. Same way, here also electron withdrawing, here also electron withdrawing. Now this hydrogen, it was again taken by the base, so it become N-bromo anionic amide. Means here anion is the present, that is the negative part of this nitrogen. From here, simple, this Br will get eliminated in the form of the NaBr to stabilize the nitrogen. So Br will get eliminated. Now here, what will happen? So now this is the simple case. What is this case? That here you will get a nitrine. So this nitrine, it is again unstable species. So this nitrine on rearrangement gives isocyanate, which on addition of the water gives the carbamic acid. This alkyl carbamic acid, and which on after heating removal of the carbon dioxide and formation of the amine, So here this clear this rearrangement, it is an intramolecular rearrangement. So this is an example of intramolecular rearrangement, and this reaction is performed in aprotic solvent. Now question is that why this reaction is performed in a aprotic solvent? What is aprotic solvent? The solvent which contain proton, simple water. Ethanol, which contain proton. Aprotic solvent, carbon tetrachloride. Aprotic solvent. Did you understood? Aprotic solvent means the solvent, a chemical species which does not contain any kind of the proton. Now, what happens if this reaction is performed in a protic solvent? Let's see.
Sir, we will know.
So, your intermediate nitrate when added or performed in the protic solvent means the solvent which gives the proton, then immediate N-hydroxyacetamide will get formed. So that's why to avoid such kind of side reaction, this reaction is performed in a aprotic solvent. So what are the aprotic solvent? Carbon tetrachloride. That is the aprotic solvent. Did you understood it? Did you understood or not? Okay. So this reaction is called as the Hofmann rearrangement. If this alkyl group contains electron donating group, reaction is very fast. Reaction is very
fast.
And opposite of that one, if this alkyl is electron withdrawing group, reaction is very slow. So this is the migratory aptitude of this one. Though there any group is present, meaning that one product will be the same. Means if here electron donating group is present, then it will use more product. If electron withdrawing group it is there, it will take long time and less product. If long alkyl chain is there, then that reaction become very sluggish, very slow. So this reaction is called as the Hofmann rearrangement or Hofmann bromide rearrangement. So did you understand it?
Yes, sir.